biological standpoint, wetlands are very diverse. They are very highly productive, meaning that they convert energy from plants and transfer it up the food chain to animals. If you're in a classroom, you'll find that studying ecology, that wetlands are among the most productive systems in the world.
For me, the passion of wetlands is to restore what we've broken, to try and get things back to a semblance of what they were. But I think that they're so subtle that it takes a little while to fall in love with them and to understand how complex they are and how integral they are to the natural systems of the dunes, the ocean and the estuary.
We need to really understand the biology of the organisms that live in such habitats and how these ecosystems function. And once we understand these things, then we are in a better position to restore these habitats, create and restore such habitats.
Historically, you know, wetlands were seen as a wasteland or a breeder of mosquitoes, and all the history of our country, we've drained our swamps and that was seen as good. We were removing pests and disease and reclaiming land for farming and then eventually for development.
Well, in general, what has happened to coastal wetlands in Southern California is that they've been pretty much destroyed. Depending on the study that you might reference, between 75 and 95% of the original coastal wetlands in Southern California are gone. Therefore, we're working with the remaining few acres, and many of the remaining existing acres of wetlands here in this region are in pretty bad shape. They're very heavily impacted by human beings, and we're dealing with water quality issues that are very serious. We're dealing with simply the loss and fragmentation of the actual habitat.
So if we can turn it around and actually create more habitats so we're not so fragmented, I think that that can only provide insurance that these species will survive in the future. The endangered species that get all the attention in wetlands are the light-footed clapper-rail, which is a small bird that very secretive that inhabits the lower marsh. Then there's a state endangered species called the building savanna sparrow that inhabits these upper high marsh areas. And then there's some peripheral species like least terns, which inhabit the dunes, and the snowy plover, which also inhabits the dunes out here. The ultimate goal is, at least based on our 1990 or 91 environmental impact statement, is to restore a good deal of this southern end of the estuary that had been filled, that had formerly been wetland. I think we're in the process of refining that. It's probably not quite that large because some of these high marsh areas that we identified for restoration have a function and are considered wetland now, even though they're high marsh.
Our restoration approach involves restoring wetland habitats, but we're also concerned with restoring the tidal prism of the estuary. The tidal prism, in a nutshell, is the volume of water that's exchanged in each tidal cycle. By lowering elevations and creating the salt marsh, we're allowing for a greater volume of water to circulate in the estuary. And this tidal flushing is very beneficial to maintaining the river mouth and the circulation within the estuary. We've learned from developing smaller then larger projects, carefully establishing what works as we go. So that's led us to create the model marsh here at Tijuana Estuary.
The records we use to do a lot of the restoration today came from maps back in the about 1850, and the south end of the lagoons and the saltwater creeks, the tidal prism, have been compromised considerably since then. Those are the areas we're restoring today.
It was the disturbed nature of this part of the estuary that made it ideal for the first phase of the tidal restoration project. We wanted to minimize impacts to any kind of functioning salt marsh and concentrate our restoration or creation efforts on areas that were primarily upland and primarily dominated by non-native grasses.
A small-town nonprofit organization and a small university research lab are at the forefront of our restoration program. We've worked with Pearl and SWIA for over 20 years to develop this restoration program. We, in 1997, put our first project in the ground. That project's a great success. It's located near the Estuary Visitors Center in Imperial Beach, and it's 2 acres in size. And the model marsh is some 10 times its size, and anticipating good results, we're planning to move on to a yet larger scale restoration. An important part of our program is that we started small and adapted our designs to new information.
We were looking primarily at how to establish certain types of plants and how they competed, and I think we got a fairly good grasp on that. But some of the unknowns are some of the things we're seeing here at the model marsh. How do we create hydrological regimes? How will they maintain themselves? And so I think we've moved from looking at just simple like plant-on-plant interactions to how we can create the overall system. Whenever you're working in a salt marsh that has endangered species, in this case the light-footed clapper rail, your construction activities are constrained to avoid the breeding season of that species. So in this case, we needed to mobilize and begin work immediately after the breeding season, which is the end of September, and complete our project before the beginning of the next breeding season, which was mid-February. One of the first steps in that process was to survey in the perimeter of the model marsh, establish the elevations for the rough and for the finer grading. Following the rough staking, the first step is to what they call grub the area, which is to remove the vegetation that's grown there. Again, that's one of the reasons why we chose the non-native grassland area relative to natural marsh, so that we could disturb as little of the natural marsh as possible. Initially, we wanted to remove the top foot or two of soil, which would be relatively non-saline, and set it aside. Excavate the rest of the marsh plain and the tidal channels and take that more saline soil, place it first in the quarry, and then cap it with the non-saline material. However, the contractor indicated that his machinery would get bogged down if he removed the top foot or two, and indeed we did have troubles with the dump trucks and even the tracked vehicles working from the existing elevation. Our plan was to work from east to west so that the final excavations would be near our tidal channel that we were going to link up to, which was near the ocean.
There's some high anxiety associated with this work. There are a lot of important design details, and the project, because of the presence of an endangered bird most of the year, the project had to be constructed in the winter when the area is prone to being quite wet. In addition, early in the construction process, we ran into an important archaeological site that threw a monkey wrench into the work. Yet fortunes were with us, and the project was completed on schedule.
The critical thing is to get the elevation right, and so many times in earlier efforts, they'd get the elevation wrong. And they'd go in and grade it, it'd either be too low, just be a puddle, which wouldn't grow salt marsh plants or even function for fish habitat, or it'd be too high. Although that's not rocket science, you have to have it engineered properly so that you have the right tidal exchange. And also, we tried to create replicate units out here as part of an effort for the researchers to look at how the marsh develops. So, as much as we could, we wanted to create 3 identical systems of channels, and that was, a very intensive engineering effort.
A lot of our research that our students and scientists have done at Pearl suggested that tidal creek networks are really necessary because they provide fish with better access to the marsh surface at high tides. They provide better drainage in the system. They improve the hydrology on the marsh plain, basically. They might even bring in more plant seedlings, which then recruit onto the marsh surface. So that was all done in a monitoring context with some experimentation here and there. What the model marsh here provides us with is a great opportunity to now test scientifically the role that tidal creek networks play in ecosystem development on the marsh surface. So what we have here then is this 20-acre created area with 6 conceptual cells, 3 without tidal creek networks and 3 with tidal creek networks.
One of the concerns about constructing a marsh in this area was that flooding either by the Tijuana River Valley or from Goat Canyon, which is adjacent to it, would result in sedimentation that might fill in our marsh. So in order to protect the marsh from that, we built a small berm around the perimeter. Approximately 4 to 5 feet of soil was removed in order to reach the marsh plain. And as it was removed, the groundwater started to rise. Initially, the area stayed relatively dry and we were able to work on it. As the groundwater rose, it became quite soft. It was hard for individuals to walk around in, and it was hard to get machinery down then to do the fine grading. In order to determine that the marsh was constructed to its tolerances within 1/10 of an inch, the elevations had to be checked frequently by the surveyors. Right now they're just cutting and loading, which is kind of what we envisioned them to be doing, but we didn't have our permit to haul. So they're just cutting it back, and then they're hauling it out. And it's moving pretty well. Pretty pleased. The project was constructed from east to west, and the first series of tidal channels that were constructed were somewhat artificial looking. They had square edges and they were straight lines, and we mentioned to the contractor that it looked somewhat artificial, so he modified his construction technique for subsequent systems and made them more natural looking.
The idea of using excavated material for beach nourishment is a really important part of our restoration concept. The barrier beach and dune system that once existed here is very much depleted as a result of human development in the area. Consequently, our restored salt marsh is vulnerable to being destroyed by high waves overtopping the depleted dune system.
Originally, we wanted to put the sediment that we excavated for this marsh in the ocean as not just for disposal but for beach replenishment. But the Corps of Engineers typically requires that sediment be 80 or 90%, the grain size be 80 or 90% compatible with the receiving area. So the beach itself is probably one of the coarsest grain sizes of any sand. And in here we found that it was fairly fine silt.
We intended to use the sediments excavated from the model marsh to rebuild the barrier beach, and we weren't able to do that. However, that's going to be a key issue to explore as we begin planning for the next phase of restoration here.
But since we were unable to put it in the ocean, we used it to restore an abandoned quarry that's about a mile or half a mile away, and we trucked the material down there and put it in a stockpile. We moved approximately 100,000 cubic yards of material, placed it on a stockpile site that was approximately 7 acres in size, and then we had to wait until the next year to move it into the quarry. So we have to get it all the way to where there's just this last little piece, then we're going to transplant, and then we'll breach. Because it can't sit in there without tides for very long.
That's what I wondered.
So it's all up in the air. They were predicting middle of the month, but it's already the 8th. I would say they're not going to make that.
Okay.
But they are moving quickly, as you see, and as they peel back, they'll expose that zone that we're going to plant with Spartina. But I guess, again, it doesn't matter. We have to be almost done before we're going to transplant, because it'll just sit in there. It needs the tide.
Yeah.
And that's a little patch that just sort of recently established itself. That's the cordgrass. So it's naturally invading this part of the estuary, which it hasn't been found out here very much.
Which is a good thing.
Yeah. Another part of the project design was to provide areas that had amended soils as opposed to areas without soils. And in order to do that, the contractor had to excavate an additional foot in depth and then replace that excavated area with a mixture of kelp and topsoil that was brought
The idea for this came from that smaller system we were talking about at the visitor center, the 2-acre created marsh. There we initially tested what effect kelp amendments might have on a small area there, and we saw that the plant biomass was just tremendously high in those areas, giving an initial boost to plant development on the marsh plain. And that's the reason why we are now more rigorously testing soil amendments and the effects they have on plant development on the marsh plain.
One of the conditions of our mini permits was that we had an archaeological monitor on site while we were constructing. We found a large archaeological site right in the middle of our marsh, and we had to work around it so that we could meet that goal of February 15th, while the archaeologists were just madly running around trying to excavate at least a subsample of this site so that they could describe it. We excavated those sites and also employed a geomorphologist to tell us the history of the site. And one of the things that they did find is that it appeared that there was a series of natural flood events that filled this area, as evidenced by lenses of sand overlain by lenses of more fine material. What the archaeologists found was a very large shell midden that indicated that Native Americans were harvesting shellfish for many years right there at the mouth of the estuary.
This is probably the thickest exposure here. You can see the dark, highly organic soil is probably related to the occupation and the dumping of the shell. You can see tons of shell, mostly keone, which is like the clam shell. Also found a little bit of cultural material, some flakes and core. So the flakes would be basically chips for making stone tools.
Carbon dating indicated that the site was approximately 1,000 years old. The archaeological site was discovered in January, and we were on a schedule to complete the project by mid-February. So we had to work around the archaeological site, continue to excavate the channels and the marsh plain while the archaeologists recovered as much of the material as they could. Once the archaeologists were done, one of the last things that was remaining to do was to move the amended soil back into the final amended plot.
We're doing an as-built on the
If he's got a cannon, it's okay.
on the whole process. Make sure that it was built right.
These are just denoting spacing. There's a 2-meter spacing plot next to a 4-meter space plot. So it's the coloring of the flags doesn't mean anything. It's all going to be the Spartina. Since it's been used for research, it's critical that they're on a very even spacing. There's control plots, and there's a control plot which has no amended soil, and there's also amended soil with some sea kelp mixed with the native soil. And within those two groups, you have a spacing of 4 meters next to a spacing of 2 meters. This is 40 over here, and this is 105 here. So that's
In addition to looking at the development of this marsh with tidal creeks and without tidal creeks, we also tried to create 3 bands of habitat. A band of habitat that was primarily mudflat nearest the main channel, a band of Spartina foliosa or cordgrass in the mid-low marsh, and then a mid-marsh area that would be for a mosaic of plants. Whenever you're planting cordgrass doesn't grow well from seed. It mostly grows vegetatively in nature, so you need to have a donor site. And the U.S. Fish and Wildlife Service in the northern end of the estuary was kind enough to allow us to harvest Spartina from the estuary. And what we try to do is selectively thin existing stands. We have what we call a plug of Spartina. It's approximately 6 inches in diameter, dug by hand with shovels so that we get a nice root mass along with our aerial stand of Spartina. And this is a process that we've used quite a bit down at Tijuana Estuary. It's usually very successful, and it was in this case. Our target goal for survival of the plantings at the model marsh was 80% by the first year and 100% thereafter, and we exceeded those goals. Spartina is a plant that requires daily tidal inundation, and we had quite a bit of Spartina that we needed to plant, and we couldn't open the model marsh to tidal influence or else we'd get swamped. So we had to rapidly plant these plants, approximately 3,000 plants, on the marsh plain, and then open it to tidal flushing before they died. So this was one of the last things we did, plant the Spartina. Once it was in, we breached the dam that was keeping the tide from inundating the model marsh. We breached the dam that was preventing the tide from inundating the model marsh on February 14th, 2000, one day before our scheduled completion. And it rained that day, and that was one of the few days in the whole winter that it had rained.
All right, well, condense.
And soon after opening, we saw a lot of movement of sediment. It was a period just after heavy rains, and a lot of sediment was moving around on the marsh surface, which is to be expected in events like these. We have also seen that little natural creek areas have developed on their own. Basically, nature has taken its own course and developed these little creeks in areas which were supposed to be without creeks. So we have seen that happen. We have seen several fish species have readily moved into the marsh as expected, and in fact 2 species, the California killifish and the longjaw mudsucker, are actively using the marsh plain at high tides, presumably for feeding. And we'll be doing some enclosure experiments later on in the season to see if feeding is higher in areas with and without creeks or not.
The plants are growing well, the plants that we planted, and we are seeing some natural invasion of other saltmarsh species. The researchers that have been looking at the fish and the birds have come up with some real encouraging numbers. There's a high use of shorebird use on the mudflats that we've tried to create out here, which indicates that there is a benthic fauna that supports them. And the people who are looking at the fish say that there's quite a bit of diversity in the fish that's similar to what we find in the natural north end. So in a small or a short period of time, we've taken an upland area and turned it into a wetland that at least has quite a bit of the functions of a natural wetland.
I think we have a great undertaking here. I'm particularly excited about the model marsh because for once, this is one of the largest experimental projects in the coastal wetlands that has been going on in the country, I would say. And it's particularly exciting because for once it offers us an opportunity to work in an experimental setting on a large scale. And really, when you work with ecosystem functions and development, you really need a scale like this to find out how ecosystems develop and what good methods are there to restore such ecosystems, how things are connected and how they function.
I'm very pleased with the Model Marsh project. The results from the get-go were just very encouraging. I remember going out there only about a month after it was first opened to tidal action and just being amazed that there were already birds using the spot, and all the formal monitoring and research that I've heard about over the last year has been encouraging. Initially, there wasn't a lot of support for conservation in Imperial Beach. SWIA was kind of a lone wolf, and this community, like most others, was more interested in exploiting the environment. But after many years of work, the construction of a visitor center, people here really have come to appreciate what's at their doorstep.
It took them a long time to come to accept the long-term vision that a few of us felt that we had. And now you hear people that are coming in and buying particularly more expensive housing. They love to be able to back onto the estuary and look at it and have the ocean on the one side and this treasure on the other. And they really love to see the birds, because frankly you see much more bird life in the estuary and wild things than you do in the ocean at their front door.
Having made some good progress in the restoration field, we're now interested in helping Imperial Beach find ways to capitalize on its investment in conservation. Clearly, ecotourism has potential here that hasn't been fully developed. We believe that it's both sustainable and that it has a light touch and is appropriate for the area. In the end, we may find that the model marsh has equal benefits for the human community as we know that it has for the fish and wildlife. We have a real interesting example here of little people, community-based planning in a sphere that's often dominated by much bigger organizations and interests. And I think it's something that is distinctive about Tijuana Estuary, and certainly something that this community is rightfully very proud of.
moving pests and disease and reclaiming land for farming and then eventually for development.
Well, in general, what has happened to coastal wetlands in Southern California is that they've been pretty much destroyed. Depending on the study that you might reference, between 75 and 95% of the original coastal wetlands in Southern California are gone. Therefore, we're working with the remaining few acres, and many of the remaining existing acres of wetlands here in this region are in pretty bad shape. They're very heavily impacted by human beings, and we're dealing with water quality issues that are very serious. We're dealing with simply the loss and fragmentation of the actual habitat.
So if we can turn it around and actually create more habitats.
Our restoration approach involves restoring wetland habitats, but we're also concerned with restoring the tidal prism of the estuary. The tidal prism, in a nutshell, is the volume of water that's exchanged in each tidal cycle. By lowering elevations and creating the salt marsh, we're allowing for a greater volume of water to circulate in the estuary. And this tidal flushing is very beneficial to maintaining the river mouth and the circulation within the estuary. We've learned from developing smaller then larger projects, carefully establishing what works as we go. So that's led us to create the model marsh here at Tijuana Estuary.
The records we use to do a lot of the restoration today came from maps back in the about 1850, and the south end of the lagoons and the saltwater creeks.
For me, the passion of wetlands is to restore what we've broken, to try and get things back to a semblance of what they were. But I think that they're so subtle that it takes a little while to fall in love with them and to understand how complex they are and how integral they are to the natural systems of the dunes, the ocean and the estuary.
We need to really understand the biology of the organisms that live in such habitats and how these ecosystems function. And once we understand these things, then we are in a better position to restore these habitats, create and restore such habitats.
Historically, you know, wetlands were seen as a wasteland or a breeder of mosquitoes, and all the history of our country, we've drained our swamps and that was seen as good. We were removed. From a biological standpoint, wetlands are very diverse. They are very highly productive, meaning that they convert energy from plants and transfer it up the food chain to animals. If you're in a classroom, you'll find that studying ecology, that wetlands are among the most productive systems in the world. We're not so fragmented. I think that that can only, provide insurance that these species will survive in the future. The endangered species that get all the attention in wetlands are the light-footed clapper rail, which is a small bird that very secretive that inhabits the lower marsh. Then there's a state endangered species called the building savanna sparrow that inhabits these upper high marsh areas. And then there's some peripheral species like least terns, which inhabit the dunes, and the snowy plover, which also inhabits the dunes out here. The ultimate goal is, at least based on our 1990 or 91 environmental impact statement, is to restore a good deal of this southern end of the estuary that had been filled, that had formerly been wetland. I think we're in the process of refining that. It's probably not quite that large because some of these high marsh areas that we identified for restoration have a function and are considered wetland now, even though they're high marsh.